So we are going to talk about some laws for DC machine, generator and motors. The separately excited DC motor, self-excited DC motor. So these laws are needed for the exams where question comes. So at first we need to know what is separately excited DC motor. Separately excited DC motor, as we know, the field winding is not connected to the armature winding. The field winding is not connected to the armature winding. It is not connected to the armature winding. Okay, they are separated winding. That's why we call it separately excited DC motor. From the figure you can also see that this is the field winding, this is the armature winding, this is the terminal voltage, line current, armature current, and this is the field current. So there are actually two laws about separately excited DC motor. One is E1 by E2 equals N1 by N2. This is when phi is constant. When phi is constant, phi proportional to armature current. So we can write this equation. Another equation from where we can find the rotation of the armature. From this equation we can find the rotation of the armature, where N1 equal to N2 equals N1 divided by N2 equals E1 divided by E2 equals Vt plus Ia Ra divided by Vt Ia to Ra. So if the value of induced EMF is given, we can, from this side we can find N1 or N2, E1 or N2, or if only terminal voltage is given, we can use this from N1 equal to N2 equals Vt plus Ia1 Ra divided by Vt Ia to Ra. Ra is the armature resistance. And for self-excited DC generator, we need to know that the self-excited DC generator has three kind of generator. First, another thing is that in separately excited DC generator we have discussed, but the equation comes here. Do you know how the equation came here? The equation is equals induced EMF equals the voltage drop from here to here. Okay, so as we know, the current is going in this way to this way. For generator, the voltage drop across all of this equals the generated EMF. That's why we write induced EMF equal to terminal voltage plus armature current into resistance. This is the armature drop. But what will happen if this is a motor? For the motor, in case of motor, it will be back EMF equal to Vt minus Ia plus Ra. I think you are actually, I think the lighting is good now. Let's go. So this one is the for motor equation. Sorry, this one equal to Ia into Ra. So how does it come? This terminal voltage you can write in this way. First, terminal voltage, the drop is equal to back EMF plus the drop in the armature side. So the drop in the armature side is equal to Ia plus Ra. From here we can write back EMF equal to Vt, I mean terminal voltage, minus Ia Ra. This is the separately excited DC motor. DC motor's equation is this. Okay. Now coming next, the self-excited DC generator. And there are three types: shunt, series, and compound. We'll come next why it is called compound, because there are such type of field winding compounded, so we call it compound generator or motor. And this compound generator can be divided into two. One is cumulatively or another is differentiatively. So in cumulatively DC generator, the two full field winding help each other. In differentiatively, compound DC generator, the two field winding oppose each other. That's why we call it differentiate. I mean differentiately. Cumulatively means it added up. Okay, that's why the two winding helps each other. So first, the shunt generator, DC shunt generator, the equation is like that, E equal to B plus IA RA. Okay, we can add the voltage drop. Previously there we can also we can add voltage drop if it is mentioned. If it is not mentioned, then we have to omit it. But if they say consider brush voltage drop but the value is not given, what will you do? You will take this brush voltage drop as 1 volt. Okay, remember it is important. They may mention the drop is 1 volt. They may also mention the consider brush voltage drop but the value may not given. This is the second case. And the third case, they may not mention this brush voltage drop, then you will take it as 0 volt. Okay, so in case of shunt DC shunt generator, we know the current, armature current is going in this way to that way for the line current, and this one is the shunt or field current. Okay, see, one field is shunted parallel to the armature winding. That's why we call it shunt DC generator. And field winding is parallelly connected. Field winding is parallelly connected with the armature winding. That's why we call it shunted. So the equation of current in case of DC shunt generator, IA equals to IL plus IF. This is the equation for current. It is important. You will find it many exams. You will need this equation to find it. And how you will find this field current or shunt current? From this equation you can find field or shunt current. The terminal voltage. See, because this is in parallel. This is in parallel with this, with this. So the current IF is going in this way. IF we can write, or I shunt we can write, terminal voltage divided by field resistance. It can be, you can say shunt or field. In this way you can find the shunt current. Okay, and then you can add it up with the line current and you will find the armature current. So when phi is constant, when phi is not constant, the equation is that for this we have to go in depth. I hope you have studied DC machines, so I think I don't need to go in that kind of depth for this. So the back EMF, I'm talking about the motor. The back EMF equal to K is the constant flux and the rotation of the armature. Okay, when phi is not constant, we can write, if two type of magnitudes of given of the same motor, we can write as it is. But if they say that no, the phi is constant, magnetic circuit is linear, then in that case, if you write this, you can cancel out these two, and you can write EV1 divided by EV2 equals N1 divided by N2. From here you can find the back EMF of one side to another side if for two equations. Okay, this is important. And including torque equation, you can use this. Including torque equation, if a question is given, you can use this torque divided by armature current equal to K prime equal to EV and the angular velocity. Angular velocity is omega equal to 2 phi n divided by 60. We know that, right? You know that. Actually, the developed power is equal to as I have also already written, developed power is equal to torque into angular velocity, or it is that developed power is equal to back EMF into armature current. From this equation, see, equaling this, we can write this. Okay, from this you can write this, and from where, using one side. Suppose you have given torque and the armature current, and you are said to found the back EMF. Okay, from this you can find K prime, and then from this side, if omega is given, angular velocity is given, you can find the back EMF of the motor. So if this is a tricky question, tricky law. Dr. Afroz Alam, you can search in the Facebook. He already showed this. I am inspired by him. Thanks to Dr. Afroz Alam sir. Okay, you can find him in YouTube. Okay, so this is the equation for DC shunt motor. Torque divided by armature current equal to K prime EV divided by omega. From this you can find back EMF or torque or armature current, everything. Okay, but first thing first, you have to, the very basic equation of shunt motor is back EMF divided by back EMF of the back EMF 1, back EMF 2 equals rotation 1, rotation 2. So from this you can, when it is phi is constant, when phi is not constant, this is 1, this is 2, and this is 3. Okay, sorry, maybe I have not the camera was not that much. This one is the number 1 question, number 1 law, number 2 law, number 3 law. Okay, that's it. Let's go for the next slide. So in case of series DC motor, or you can say DC generator, there is a winding connected in series with the armature, so that's why we call it series DC motor. Armature winding is connected in series with the field winding. Okay, that's the difference between series and shunt. Shunt was connected in parallelly, field winding was connected parallelly with the armature winding. Or in series winding, in series DC motor or generator, the field winding is connected in series with the armature winding. So this is the equation figure of the motor. The current is this is the terminal voltage, so supply is given. This is the line current, is also the field current, it is also armature current going through this, and this is the back EMF. Okay, so for back EMF we know as earlier, back EMF equal to K phi omega and torque equal to K phi Ia. But at first we have already said that armature current equals to series current equal to line current. Okay, this is also the field current. Series is the field current. Okay, and for a generator, I will come next later to the generator. At first we are talking about the motor. So the terminal voltage Vt equal to EV plus Ia Ra plus IL RAC. This IL equals to Ia equals to IF, whatever you say. So you can write EV plus Ia Ra plus Ia, the series winding or field winding, back EMF plus taking common Ra plus R AC মানে series winding. সুতরাং hence the back EMF can be written as sorry, my lighting is too bad, I am really sorry. So back EMF can be written as terminal voltage minus Ia Ra plus taking Ia common, series winding. This one is for the what? Motor equation. And for generator, since the current will be go out in this way, it will be terminal voltage plus IA RA plus RSE. So this is the main thing. This is the main two equation. For this one is the motor, this one is the generator. I have already written it there. Okay, we are just making it clearing it for myself also, and if you are confused, you can actually watch my lecture. I am not really expert, but I am trying my best to make myself understand and make some of you understand it if you are confused. But don't be confused watching my lecture. Okay, if you confused watching my lecture, you can just leave it or skip it. Okay, when phi, actually for the magnetic linear circuit, phi is proportional to armature current. So this is the one equation from where you can find torque for the respective armature current. Okay, this one is IA1 square, IA2 square, and this is the torque 1, torque 2, and this is the K prime. From this equation you can, from the math, find the solution. Okay, and for we know that EV equals to I can write it here, back EMF equal to or you can write from this one, this is the omega, but if the two magnitudes of the two cases are given, you can use this equation. So equaling this, actually this was the main equation from where we have derived it. Cross multiplication, but in case of omega, we know, since we know W omega is equal to 2 phi n by 60, if you put it in here, in case of instead of W, or in case of omega, if you put 2 phi n by 60, you can write it as this one. So this is the main equation from where you can find the rotation of the armature. And for the KVL equation, as we know, the KVL equation, since you have seen the field winding is connected in series with the armature winding, you can find the drops along doing KVL. The KVL equation you can see here, I have written it, and this is for motor, this is for generator. Okay, now coming next to the DC short shunt generator. One is short shunt generator and another is long shunt generator. In case of compound generator, there are two types. One is cumulatively or another is differentially. In cumulatively, one field winding help another field winding, but in differentially compound generator, one field winding oppose another field winding. So in case of differentially, we can call it long shunt generator, and in case of short shunt generator, we actually call it cumulatively or short shunt generator. Okay, so again the armature current is actually important. For armature current equals to armature current is going in that side to this side and this side. So armature current equal to line current plus shunt current or field current. Okay, this on the equation for armature current, and the induced EMF equation is E equal to V, I mean terminal voltage, plus IARA, the armature current drop IARA, plus IL RAC. That series, one series winding is connected in the cumulatively compound generator. That's why it is called cumulatively compound generator or short shunt generator. It is shorted, and we can find IL plus RAC. We can add it up for the total voltage, from where you can find the answers of induced EMF of cumulatively compound generator. And the shunt current, how will you find it? The shunt current is, this one is the shunt current, right? This one is the shunt current. So the shunt current is equal to, the shunt current should be terminal voltage. See, this drop is equal to this drop, right? Because we have a winding here. Okay, earlier we did not have any winding, so we just took this drop. Now we are taking the full drop because we have the series winding in here. So shunt current equal to, shunt current is equal to terminal voltage plus line current into series winding divided by shunt resistance. You understand? This current going inside in there, I equal to V by I, right? So the voltage is the total drop in here, terminal voltage plus series drop. Okay, terminal voltage plus series drop, and divided by resistance, I mean the shunt resistance or field winding. Okay, I have also written here, you can see this equation. Now for differentially, as we know, the one winding is actually opposing another winding. In this case it is almost like previous shunt generator, but we have a series winding connected in series with the armature winding. Okay, and so you can see that that's why one field is actually just opposing another winding, and the net flux produced by the net flux is produced is totally getting decreased in this case. And the armature current, you can see the armature current equal to line current plus shunt current. Okay, this is the equation for armature current, and the voltage induced EMF for generator. We are talking about two generator actually here. You know that if you discuss about generator, you can find the motors equation. It is so easy. So the induced EMF equal to IARA plus IARAC. Okay, you can I have written it shortly. You can understand IARA plus this drop plus this drop, this drop plus this drop. Okay, this is the main thing. E equal to induced EMF equal to IARA plus IARAC plus terminal voltage. This total drop. Okay, this total drop is equal to induced EMF. And shunt current, how will find shunt current? It is now easy. Shunt current equal to terminal voltage. See, we don't have any field winding here, so you can just take this terminal voltage drop from here to here. I is equal to V by R. R is equal to the shunt field winding shunt. So from here you can find the shunt current. Thank you. I know this is very confusing. Maybe you have get disappointed by seeing this, but I tried my best for myself to make understand. and I hope you understand also. So I will upload a very short video about this law. You can search it later. So thank you for watching.